we looked at moments and the rules around them to know when, for example, a beam will balance. So for instance, let's say that we have a beam like so, and it is part of a seesaw, and there will be a turning point there, which sometimes we call fulcrum or pivot. And so it can turn that way, or it could also turn the other way. So clockwise in this case. Good. Then the idea is if we add certain weight on one side, let's say on this side, we put a very large bird, and on the other side, we put a little rabbit, then is it going to balance? Now, if they are at exactly the same distance, we already understood in class that they will balance. But what will happen when one of the distances is a lot larger? Let's say, for example, we continue this beam and we take the rabbit and we put it over here. Then will it balance or not? So to answer those questions, we need to calculate what we call the moment on the left side. So let's draw an imaginary line that divides this in half. So on the left, we are going to calculate the moment, which is the force times the distance. Now, which force? It is the force that the Earth exerts on that little animal. So it is the weight, and let's assume that that force, for example, is, let's say, 200 newtons. And let's assume that this ostrich, which is a bit heavier, is pulled with a force of, let's say, 600 newtons. Then the moment on the left is just going to be assuming that this distance here is, we're going to say, 4 meters. And that same distance on the other side here, we're going to say is 2 meters. Then the moment on the left is the force, which we already found, times the distance between the force, so the rabbit, all the way to the fulcrum, or the point where it's turning. So that's going to be 200 newtons times 4 meters, which will be 4 times 2, 800 Newton meters. Great. So we already have that one on the left. That's our result for the moments on the left side. And we just need to repeat the same process on the right. So the moment on the right is going to be the force 600 times the distance 2, 1,200 Newton meters. Now, to know if it will balance, what we need to do is compare these two numbers. So if the one on the right is larger than the one on the left, then it's very easy. It is simply going to turn that way, clockwise. Okay, so this is how we would find out if the beam will balance or not. Now, how much further would the rabbit have to go for this to work, for it to balance? Well, why don't we try, for example, with 5 meters, the beam that is 5 meters. So actually, let's try a little bit bigger. Why don't we try with one that is 6 meters long? So if it's 6 meters away, then the distance that we multiplied with down here is going to be 6. And our result after multiplying 200 times 6 is going to be 1,200. So in this case, then we will not have any turning effect, and instead it will just balance perfectly.